To do these things, great. If not, don't worry, I'll show you in a minute. But one thing you should write down is this API key, because I'm going to ask you to type it in somewhere else in a minute. So just I haven't shown you yet, but I will show you in a moment. So if you just make a note of it so that you know what it is. Okay, so I guess, should we get started? We ready to record? Okay, so hi everyone, thanks for coming. I'm Donald Sturgeon, and I'm going to be talking today, giving you a bit of a demonstration of some of the text mining facilities that are connected with, although not really, as we'll see, built into the Chinese text project, ctext.org. And what I want to do is to give you some really concrete examples of using text mining to work with historical Chinese texts. The examples that I'm going to use are classical Chinese texts from the pre-Qin period, but basically all of the techniques that I'm going to discuss and give you examples of are very widely applicable and can be applied to lots of different materials. So I'm just going to give some examples, but I'm going to show you them through a tool which hopefully will be very easy for you to reproduce all of the examples that I'm showing you in exactly the same way on the lab computer or on your own computer at home. And the point of that really is that I hope that you can then reapply these to materials that are actually of interest to you. So we're not going to be doing hugely sophisticated things, but the things that I am going to show you should be things that are completely reproducible by following fairly straightforward steps and without requiring you to sort of learn a programming language or learn a huge amount of technical stuff just to reproduce these things. And I should say, please, since we're a small group, stop me at any time if anything that I'm saying doesn't make sense or if you have questions, because I'm going to be skipping through a lot of detail and it'll be useful to talk about things as we get to them, I think. So I'm going to start with a few slides and then I'm just going to skip to the online platform. Is there some way to make this show as a full screen on the main screen? Does anyone know? Oh, maybe it's this one? Okay, that will do. All right, yeah. Okay, so I'm going to spend, how many of you have used ctext.org, have used the Chinese text project? A few of you? Okay, good. I'm not going to spend a lot of time introducing that project. It's a database of historical Chinese materials with various functions, some of which are related to the types of text mining that I'm going to try and introduce in this workshop, which is the aspect of it that I'm going to focus on more today. There's other stuff too if you're interested in it. So I'm going to mention some of the basics of ctext.org, how you find materials on it. So the idea with text mining is that we take historical, in our case, textual materials which have been transcribed into some sort of digital form, and we try and get a computer in conjunction with us as researchers to show us interesting things about these materials or extract statistical facts about them or extract information in certain ways. And in general, a prerequisite for that, or one prerequisite for that, is that you have digital copies of these texts in a format that's compatible with whatever tool set that you want to use with them. So for that reason, I'm going to show you how to get these kinds of materials out of ctext.org and also how to help with the process of creating new transcriptions of materials if the text you work with are Chinese and they haven't been transcribed digitally to an adequate extent. There are some cases where ctext.org will help you or provide functionality that can assist you in transcribing these and creating digital copies of them for the first time. So I'm not going to spend too much time on that, but I want to show you how it works. And then what I'm going to spend a bit more time on is introducing a digital tool that can be used for interactive textual analysis and vision. There are lots of different platforms and tool sets and ways of doing text mining. The one that I'm presenting is, of course, I'm biased. This is one which I developed myself, and that's why I'm introducing it to you. But one of the advantages of it is that it's very easy to get started with because it doesn't require installing software on your computer or learning a programming language, and it's also designed to work with these materials from ctext, which is why I'm introducing these two things together. But it's really important to mention that the tools for textual analysis and visualization that I'm presenting are not really part of CTEXT. They're not tied to the materials in this library. We're going to use them for the initial examples, but if you want to use different materials that don't come from this project at all, that also is totally fine. And in fact, they don't actually have to be in Chinese either. If there's time, I'll show you some examples with English or modern Chinese or some other languages. So just talking about CTEXT itself, you don't need to know a lot about the project to follow what I'm saying about it today, but the main thing about it is it's a textual database, a full-text digital library of historical Chinese materials. So it has a lot of different types of stuff in it, but two of the most fundamentally important types of material are image sequences of historical editions. So in this case, the image on the left, this is just one page from a Chinese work that's now in the Harvard Yenjing Rare Books Collection. And all of the Harvard Yenjing Rare Books Collection for Chinese has been scanned and included in this project. And on the right-hand side, you have a transcription, which is of the same underlying text. So it's the textual content of this edition, but transcribed into characters so that it can be processed by a computer. And one of the main things that this library does is links these two things together so that you can search in one and navigate to the other and so on. One really important thing if you haven't used CTEXT before, or if you've just come across CTEXT from a web search and know nothing about it, is that it's not designed as a traditional text database. So it's not your sort of standard full-text digital library project where you have this kind of top-down structure following the traditional publishing model, where you have materials being, being curated through a long and complex manual editing process. Perhaps you have one team or multiple teams hand keying the materials and typing them in, and then you have other people proofreading these and copy editing them, and then finally your reviewed materials are added into your database. In CTEXT, there's no process like this at all. Instead, draft materials are put straight into a database, and you as the user are provided with mechanisms for navigating this vast amount of primary source evidence, and also for verifying the correctness of this. So this is particularly important where you have materials which have been transcribed not by experts, but by computers using OCR software, which of course introduces errors, especially when you're dealing with historical materials like these. And we can look at that if you're interested, but that's not what I mainly plan to talk about today. The user interface for the site, which we won't spend that much time on this today, I'm just mentioning it so you know how to find some of the basic things that we need, looks something like this. The key point is that a lot of the important navigation elements are down the left-hand side of the page. So there are things like changing the interface from English to Chinese or to simplified Chinese characters, finding things. The only things that we really need today for the rest of the workshop are the title search function down at the bottom. If you want to find materials that you are interested in or follow some of the examples that I'm mentioning, you'll need to know how to find texts in this database. That's basically done by searching for something in this box here at the bottom. And the other thing you'll need is to be able to create an account and log into this system. And that again is something which appears down at the bottom left. Because it's not a traditional database with this kind of standard review process where only fully curated materials are input into the system, there are different possible types of material in the system depending on what their origins are. And these are indicated in various ways, one of which is using these little icons with different colors corresponding to different search results that you get when you might search for something. So there are basically four possibilities here. One is that you have this sort of green icon, which corresponds to something similar to what you'd find in a traditional textual database. So somebody has edited this, it's been hand typed. It should be fairly reliable. You also have things which are also manually typed, but which are collaboratively editable in a crowdsourced wiki system, which I'm going to show you in a moment, because I hope that you're going to participate in helping curate this data. Then you have another type of material which is the same icon but in black and white, and this is supposed to represent a text which technically has all the same properties as these other texts. It works in exactly the same way, but it hasn't been input by a human being. It's been input by a computer using OCR. So this is kind of a warning sign that this probably contains mistakes introduced by this automated conversion process. And the last kind of icon you don't really need to worry about today, because this just represents the scanned image of these historical materials. So the kind of thing that you might see in the search results is something like this. If you'd searched for, say, the Liu Quanjie, you might have one result that looks like this. And this provides information about the edition. But the really crucial thing here is this connection to the Sikuquanshu edition here, and this little black and white icon to the left of it. This means that this item in this database is connected at a very close level to a scanned representation of this particular edition of this particular text. And that's what makes the transcription verifiable. You can search in the transcription and immediately switch to the scan of this specific historical edition to check whether the scan's accurate, and if it's not, to help with the correction process. So basically, when you're looking for texts, if you want to use them in a scholarly research context, you almost always want to find one which has this information, which has this connection to one specific edition that's verifiable, so you can actually check that. This page is meant to just make a fairly simple point, which is that in cText, if you have one abstract work, so a work like the Lunheng, for example, and that work exists in multiple different editions, say the Sibyl Tongkan or the Sikuquanshu or whatever else, each of these editions will be treated essentially completely differently in cText. So there'll be one text in cText representing the transcription of each of these separate editions. So this is just a kind of design decision in the database, but it's something to be aware of when you're looking for materials. You'll very often find if you search for a work by title, there are multiple results, one corresponding to each edition. That's intentional because although in many cases these editions will have a lot of overlap, they can diverge in various ways that makes it much more sustainable in a crowdsourcing sense to have these treated as completely separate objects. Okay, so that's pretty much all I want to say directly about cText, other than to show you a few basic pieces of functionality in it. So there are really two parts to this tutorial, and I'm hoping that you're all going to try some of these things. There's also, I'm going to give you a link in a moment. Everything that I'm going to show you, or nearly everything that I'm going to show you, is available online in the form of written tutorials that are designed for you to go through and work through step by step, probably with more detailed instructions than I'm actually going to have time to give you for each of these steps. So I would recommend, depending on where you are at this process, if you're already very, very familiar with cText, you may want to jump ahead in some sections, that you either try and follow along with the examples that I'm showing, or a mixture of that and working through these two documents that I'm going to show you. So one of the documents is going to correspond to part one of the tutorial that basically just talks about cText, and this is in the online version, this is this practical introduction to cText. And the second part, which is maybe, even if you've used cText, you may never have used this tool before, or may not be aware of it. This is the part where we actually do some experiments with text mining. And this is using something called Text Tools, which is a plugin for cText. So it's a program that's connected with cText, but is not really part of the digital library. So I guess I'm not going to go through these specific things just now, because I'm going to show you detailed examples of them instead. The most important thing to realize about text tools is that although it's something which you, like cText, access in a web browser, it's actually a program which runs on your own computer. So when you access ctext.org and you look at text there and you perform full text searches, you're sending requests to a web server that is run by cText and which performs these actions for you and gives you the results. When you use text tools, everything that happens on your computer. It doesn't go across the internet to anywhere else. It doesn't get uploaded anywhere. It happens on your computer. Okay. The other thing we'll need, and I've mainly just put it in here so you have it as a reference, because I'm going to show you the link to these slides and all the other materials in a second, is how we find the names of textual objects in cText in a way that a computer can understand. So, like I've already said, many texts in cText will exist in multiple copies because there'll be multiple different editions. If we want to do text mining on any of these, we need to be very specific about which specific transcription of which specific edition it is that we actually want to use in some other project. So to use, for example, in text tools, as we're going to be doing today. And in order to facilitate that, every textual object in ctext has something called a URN. And these URNs are basically just names or identifiers for a specific copy of a specific edition of a specific text. And it's very easy to find these once you know about them. You just look at the bottom right-hand corner of any particular textual object. So I'll show you this in an example in a moment. So this is the tool that we'll use for the text mining today. This is text tools. I'm not going to go through how to use it in detail yet. It will be simpler just to look at some examples. But I do want to highlight the general structure of how it's organized. And it's basically organized into 4 components. So starting at the top, we have all these different buttons, each of which corresponds to some particular function. Obviously, the one on the right, the help button here, is somewhere where you can get information about what the tool does and how it works. But each of these other tabs here will switch the rest of this page to some content that relates to a particular function. So if you want to use the similarity function, you hit similarity, and all the stuff below it will change. After that, the second step in the workflow is generally to select the textual objects that you want whatever function to apply to. And you can either load these from ctext, or you can load them from files on your computer or from other sources. But once you have done, they'll appear here in this section. And then after that, it's a question of choosing various parameters for how you want a particular task to be executed in the blue section here. And then finally, having asked it to perform some sort of analysis, each of these functions is going to produce some kind of result that appears at the bottom here. So that's the general setup for it. It's pretty straightforward. Everything I think that I need you to access, or that covers the material that I'm going to talk about today, should be available from this URL. And as I said, you'll need this API key in a moment in a way that I'll explain. But if you open this in a web browser, you should get most of the information you need. You won't necessarily need all of it just now, but it's there for reference if you want to come back to this in a few days' time, look at some things in a bit more detail. The slides that I just showed you, you can download here if you want them. And the setup information, which I'm going to show you in a second, is here. And then below that, there are basically links to much more information. So this is the link to the tool itself, which is what we'll use when we start doing the text mining. You see it just opens in a web browser, and as I said, these different tabs will do different things that we'll look at in a moment. If you want to find more information, because we won't have time to do all of this today, the 2 tutorials that give you kind of step-by-step instructions are these 2 tutorials linked here. So each of these has a fairly long kind of set of things, including exercises to actually ask you to do specific tasks if you're not sure how exactly the thing's supposed to work. Each of these are kind of controlled examples which should show you what kind of thing it's designed to do. We won't have time to go through all of those, but if you're interested, you can skim through those later or go back to them for reminders. And then if you just want to come back and see some overviews of the kinds of things that can be done in the tool, again, there are a couple of basically blog posts here, which, again, in this case, they don't really cover all of the functionality of this tool or how it can be used for text mining. But if you want some reminders of the kinds of general things we're going to look at today, these will give you a little bit of a kind of overview of them. Okay, so the first thing I would like you to do is to do this initial setup. So the reason for doing this is so that you can ask this textual database to give you textual sources in a way that allows you to do text mining with them. And in order to do that, what you need to do first is to create an account on ctext.org if you haven't done that already. And then log into the account. So if you already have an account, you don't need to create a new one, you can just log into it. But if this is your first time using this system, what you would need to do is to fill in a username, your email address, choose a password, and then create your account here. So how many people already have a ctext account? Almost nobody. Okay, good. So please try doing this as I start going through the rest of this. Once you've created your account and logged in, I'll just log into mine. Oops. You'll see there are various options in here. Your account will look a little bit different to mine because I've been using ctext for a while, so I have some other stuff here that you won't have. But one thing which you will have will be this little part labeled API key, and this is where I want you to type in that API key that I just gave you. So you should type in or copy and paste into here the thing that says MAR-AAS 2019 ctext, and then very importantly, once you've typed that in, you need to click the button that says save. Yeah?
I started going through it and I can't get that page. Is that a page?
So are you in ctext.org? Somewhere in ctext.org? Yes, so if you're somewhere in ctext.org and you want to go back to that page, you need to go on the left-hand side down to settings. Great. Okay, so that's basically almost.
The MAR 2019 is the password.
It's the API key for today. Yes, yes, yes. The other thing which you can do here, but is not essential, is you can install TextTools as a plugin. So the TextTools program is often described as a plugin because it's designed to work very closely with ctext, but you don't actually have to connect it to ctext. I'll just show you what it's designed to do. So TextTools is going to perform various basic text mining tasks for us. Very often, to get a text into TextTools, what we're going to do is to navigate to it somewhere in the ctext interface. So for example, supposing we wanted the text of the analects, we would go into the analects, and in order to tell some external program which ctext object you want, you need to find that URN. And that is always located at the bottom right-hand corner of the page. So here, and it might not be all that clear on the projector, if you zoom in, there's a very small piece of text at the bottom right here which says that the URN for this text is CTP analects. So that's how you get the URN. And once you've copied that to the clipboard, you can then go and paste that into the TextTools application or some other application to actually get the text of this work into that system. Yep.
And that's only if you put TextTools as a plugin.
Yes, so that will, no, sorry, I thought you were going to ask a different question. No, that will work regardless of whether you've put TextTools as a plugin to ctext or not. So, okay, so I'll just show you that first. So we've got ctext open. I haven't installed TextTools as a plugin, and I just go to the link on here, link to TextTools. If I go here, in a different browser window, if you choose any of the functions, basically any of the functions here except for the ones on the right, so if you pick something like ngram, you'll see that there's a function called fetch text by URN, and this is where you would paste a URN in. So if I paste in my CTP analects and click fetch, it will go and fetch the full text of the analects from ctext, and it'll fetch it in a format that this tool understands. So it'll fetch it in a kind of consistent format, and I can save that into my list, and it'll show me that there's a text here called Lunu, and it has however many characters, it has however many sections, and so on. So the plugin aspect is actually not all that crucial to what we're doing. It's not at all crucial to what we're doing today. It's just for convenience. If you do want to install the tool as a plugin, the way you would do that is by going back to the settings page, and then in the plugin section, click on the list of popular plugins, and then just click the install link to the right-hand side of TextTools. And then you'll have to click install again in the message that pops up. The only thing that this does, which is any different from not installing the plugin, is that now if I go to any object in ctext, there'll be a link at the top that says TextTools, and if I click that, I'll get a new instance of TextTools which loads that particular text. So it's not important to anything that we're doing today, but it can be convenient. Okay. So have most of you managed to set up an account? Hopefully, good. Okay. So before we go into doing things in TextTools, I'm just going to show you a couple of basic things in ctext. So finding text should be fairly self-explanatory. As I say, you look for this title search thing at the bottom of the left-hand page. So supposing I want to look for something like the Jin Shu, the histories of the Jin dynasty. I can type that in here and do a search, and I'll get the kind of thing you might expect to find if you search for books in a digital library. You'll find all of these different entries. Some of them will have the same title, but they'll be different editions. So we have the Wuyingdian edition, and we have the Sikuquanshu edition, and so on. And so opening each of these will give you something that seems pretty similar, which it should seem pretty similar because the content of these different editions is going to be very similar. But what you'll find, and you'll be familiar with this if you've used cText to search for materials and compare them to their scanned editions, when you actually start looking through the materials, either navigating through them or searching for something, so if I search this copy of the Jinshu for Mozi, for example, I'll find that it occurs in certain places. And if I do the same thing in a different edition, I'll probably get pretty much the same result because we're just searching the textual layer here, so these two results look identical. But what will not be identical is what happens if I click this black and white icon to the left here, which represents the scanned copy of the associated text in the edition that I've selected. So if I click here, I will get the Wuyingdian edition and the specific page which corresponds to that particular part of text that I was looking at, so the same line about Mozi here. And if I do the same in this other window where I searched a different edition, I'll get the corresponding thing in the Sikuquanshu version of the text. So this is sort of the basic way that cText works for finding these kinds of materials. The same principle works, and the reason for showing you this in a little bit of detail, with materials which nobody has actually had the time or gone to the trouble or put in the effort of transcribing by hand yet. So cText has built into it optical character recognition software which can produce results from historical editions of Chinese text. If I search for the Dushu Zazhi, for example, here you'll see, and this is where the icons are important, you'll see there are none of these red or green icons, there are only these black and white ones, and the ones corresponding to the images. So they're transcriptions here, but they've been created via OCR, and so they're going to contain mistakes. And again, you can go in and look at different editions of these. Again, we can search for something that we know is going to occur in the text. Oh, it's not the example I was going to use. So this line from the Mozi by Ma Ma Ye occurs in this text. If I search for it, I'll find the corresponding page image. And here there are going to be errors. So I can find it in this edition, and I can find it in the other edition in exactly the same way. This is where cText is really quite significantly different to other mainstream types of full-text database like Academia Sinica or Chant, in that these black and white materials that have been created using OCR, these are ones where I'm hoping that you will actually play a key role in correcting these materials and improving the quality of them. So if you look carefully on this page, for example, you'll see, although the transcription is not terrible, there are certainly mistakes. So the correspondence here should be one-to-one. You should have exactly the characters transcribed here that appear here. But you'll see if you look carefully, when we get down to here, this Yue character here has been mistranscribed by the OCR software. It's probably misinterpreted this little dot here as meaning that this is a completely different character. It's actually a Che, which is incorrect. And so what you should do if you're a well-meaning, well-intentioned cText user when you're using this is to submit a correction so that this gets corrected. And this works on exactly the same kind of principle as Wikipedia, but it works using a system that's designed to work only with texts like these. So again, I don't want to spend too much time on this today because we've already spent quite a bit on cText, but the general principle is the time to correct these mistakes is now. It's when you see them on this side-by-side visualization, because it's now very clear whether or not something is a mistake. You don't need to worry about different editions. You only need to care about this specific edition and this specific page of transcription. So to correct it, you would click this quick edit button here. And when you do that, you'll get this piece of information appearing here at the bottom right. And this is just a transcription of only this page. So this is the content as cText understands it at the moment for what appears on this specific page of this specific edition. So this should contain the same mistake. It should contain this character here, which is Qie and should actually be Yue. So I can type in, you can just type things in to modify this directly. And in fact, this is also a mistake because this is not a Yue. We can just correct those. And then once you've corrected them, you click Save Changes. And as soon as you've done that, you should see these changes being reflected in the transcription here on the right, so you can double check that this is what you were expecting to see. And the other really important thing about this is that, remember we started out by looking at this textual representation of the text. In CText, these two things are really not two separate things, they're really one thing. There's only one underlying text, and it's shown to you in different ways. So here, in the full text view, it's shown to you in one way, and in the side-by-side image and transcription, the same content is shown to you in another way. So the correction that I made here to these Guyue parts is going to be reflected in here as well. So let's see if you can see that if I just highlight it here. So both of these have been changed to be correct. Because I made that correction in the image and transcription view, it's been corrected here as well. This process is completely open. Even if you've just created an account just now, the system will let you do this to CText texts. It will allow you to edit them. And so often when I present this to humanities scholars, they think this is a really crazy idea, or there are people who are really worried about this because this seems like the text could be edited by anyone however they like, and this is going to be some sort of disaster for the content of these materials. So because of this, there are all sorts of procedures which are borrowed very, very closely from projects like Wikipedia, and the most straightforward of these is this idea of a history. So if I click the history link for this text, which is displayed at the top right, it's going to show me all of the changes that have ever been made in the history of this text once it's been added into CText. So you can see since 2015 this text has changed at various points in time, and the changes that I just made are recorded in the difference between its state here as it was at the end of 2017 to its current state as it is now. And there's as in Wikipedia, there are visualizations for showing you specifically what the changes were. So this corresponds to me deleting these two characters and replacing them both with Yue. So the idea here is that other users can very easily verify whether or not the activity of this particular user has been a legitimate and helpful one. And in fact, this is also interactive, so you can just click on the links and you'll immediately get highlighted in the specific page the part that was changed so that you can go and check it. And I should mention that a lot of people do actually edit these texts. So these are all edits from the last couple of hours in CText. This is a process that's continually ongoing. People are correcting these texts and improving them. So please, if you do work with any materials like these in CText, please do help contribute to this process, because the whole purpose of this approach, and the reason that we're not doing things here in exactly the same traditional way as things like Academia Sinica's Hanji, is just the enormous amount of material which has been scanned, which is available in some edition in a digital photographic representation. The amount of material that there is such that it's not a feasible task in a short period of time to actually hand transcribe all of this. So for many materials, this is the best that we can do. We rely on helpful users who happen to be interested in particular parts of the corpus to help work on the parts that they're interested in. Okay, anyone have any questions about the crowdsourcing aspect? Because that's pretty much all I'm planning to say about it. Okay, those of you who created accounts, please do experiment with this and have a go. Yeah?
Do you have problems so far? Did you kick anybody out?
No, I don't think so. I don't think anybody has had to be kicked out. The only problem we sometimes get is that the standard for these transcriptions is always characters in the same form, or as close as possible to the same form as the historical text, and it's specifically not in simplified Chinese. Some people will just automatically assume that we're going to input things in simplified Chinese. Beyond a certain point, the system will not allow you to do that, but there's a certain amount of ambiguity because many simplified Chinese characters are historically attested traditional character, or historically attested pre-simplification characters, and so it's not always possible to be predict just looking at a specific phrase whether this is an accurate transcription or whether this is somebody accidentally inputting in simplified Chinese. But yeah, that's quite a good example, because that's a case where it's not really a question of banning users as educating users of the way that they could contribute most profitably to the overall project. Yeah. Okay, so there are various functions in the textual database that we could look at. I'm probably not going to go through all of them because there I will just mention one piece of functionality. So you'll see that there's this distinction between the green items and the red items, which is a sort of slightly arbitrary CTEX distinction in that some parts of the database are very old relative to the newer ones. So green items are not editable. But one of the features which these green items do have is this little yellow button here, which corresponds to parallel passage information. And this provides a way of looking at text reuse in particularly Pretian and Han works and a small number of related later works. So you'll see when you use this feature, you'll get various visualizations of reused content that appears in multiple places in the Pretian and Han corpus. So for example, this section here, which appears in the Zhuangzi, very, very similar kind of expression appears in the Huainanzi. And this kind of text reuse is really prevalent in the Pretian and Han corpus for all sorts of reasons, largely of textual transmission histories. This functionality was designed to provide an interface to it so that you can navigate it very effectively. The reason for mentioning that now is that this actually relates closely to something I want to show you in text tools, which is a much, in some ways, less sophisticated, but in other ways more powerful or more flexible way of identifying text reuse in materials generally and visualizing the results. So again, if you're interested in this, there's a link on the web page that I gave you at the start to a paper which describes this in the Pretian and Han, but I'm not going to go into the details of that much just now, other than to show you, if I can find it, there's a link here, more information. One of the visualizations of that project. So this graph here is something called a network graph, which is a way of representing relationships between different objects. In this case, all of the texts of the Pretian and Han. So showing you, according to these reused clusters of material that appears in multiple places, which of these transmitted Pretian and Han texts as we have them now are connected most closely to which other ones. So this is really something which is closely connected to this paper here. If you're interested, you can go and take a look at it. But which actually inspired the creation of this text mining plugin, because one of the features, or one of the obvious features to me about this representation here, so this is supposed to be showing you that, for example, the Huangdi Neijing and the Nanjing, they have a large amount of text reuse, and hence there's a line joining them together here. But as soon as you create this kind of visualization and publish it in a paper or in a static image online, you lose all of the data that lies behind it. And very often it's the data that lies behind it that's actually the interesting thing. In other words, what specifically are those instances of text reuse that correspond to this kind of edge? And a static image like this is not going to provide you with a very practical means of interacting with this data set. So one of the things that text tools attempts to do is to make this kind of data interactive so that you can, on the one hand, visualize things at a large scale. So this is visualizing hundreds of thousands of these kinds of parallels in the Pretian and Han, but at the same time actually navigate the data and see specifically what are those textual features that relate to whatever kind of visualization that you're looking at. So I'm going to move on from this just now, but if you're interested, do take a look on CText because there's quite a lot of detail about that particular example if you're interested in it. Okay, so I'm going to switch back to text tools. So the first question with text tools is how you start it. To start it, you just need this link. So you can either follow the link that I gave you here, or you can follow one of the links from CText, or if you installed it as a plugin, you will have anytime you go to any text in CText. So if I go to the Zhuangzi, say, there'll be this text tools link. Any of these ways is equally good way of starting the text tools plugin. Some important things to realize about it are, first of all, as I said, it operates entirely on your computer. The content doesn't go anywhere. Secondly, partly because of that, as soon as you close the browser window, you've lost everything that's in here. Unless you've saved it or copied and pasted it or done something with it, it just goes away. It isn't saved anywhere. And thirdly, you can have as many of these things open at the same time as you like, and each one will behave completely independently from all of the others. So each one, essentially, each browser tab is an instance of this tool. So I have one instance of this tool here with the Analects loaded into it, and I have another completely separate instance of the tool here with the Zhuangzi loaded into it. So if we want to look at things separately, or if I'm experimenting with things at the same time, I just need multiple browser tools for these. But if I want to perform the same kind of analysis on multiple objects at the same time, then I need to load the different texts into the same instance in order to do anything with them. Okay, so I guess I'll start with the simplest possible kind of analysis here. So let's see, I've got the analytes here, and I open the analytes up, and I get the analytes loaded in here. The simplest of these tools, and probably not the most interesting, is this n-gram tool. So I think if you were at Songchen's presentation this morning, he mentioned these collocations, the idea of multiple characters co-occurring one after the other. This can be one way of capturing useful information out of a text. These are basically what are called n-grams, where the n is just how long, whether you're talking about 1 character, 2 characters, 3 characters. That number is your value of n. So if your value of n is 1, then n-grams are simply character frequencies or character counts, how many times a different character occurred in a particular text. So if I, as I say, set the parameters here, most of the parameters in most of these tools will have reasonable defaults. If I set n to 1 and click run, then I should get some output here. And the output that I get is just a table that tells me in the textual object that I had loaded in the analytes, what are all the distinct characters that occur in that text, and how often do each of them occur. So in other words, this is just telling me that the characters occurred 977 times in the Lunyu. So far, this is a pretty trivial text mining task. This hasn't told us anything interesting. But one thing that I want to draw your attention to here is that a lot of the things that we will look at, and this applies to a lot of text mining tasks where you're dealing with unstructured textual resources like these, basically are building upon the fact that computers now can do things like full text search really, really quickly. They can do, so this is searched for every possible term in the analytes all at the same time, and it took, a fraction of a second, so as soon as I pressed a button, it was there. A lot of these text mining approaches are basically leveraging that fact, the fact that a computer can do fairly trivial computations, but it can do them so quickly that it can do enormous numbers of them, and that can lead to useful statistical insights. So here, so far, of course, there aren't really any statistical insights. One thing I want to mention, because it's a general feature of the tool, is that most things here are intended to be interactive. So if you click a particular item on here, you will then get, in this case, a list of all of the specific occurrences of that thing which was shown in the results there. In terms of the way the tool works, you'll also see that a lot of these tools switch you between different tabs. So when I clicked that link, I switched from the n-gram to the regex tab. The tool did that for me itself. But what that means is that if I want to go back to the previous page, I need to go up to the top and click back on the n-gram tab to get back there. So the table that I saw to begin with is still there. And if I want to search for a different thing and I click it, I'll get this result down here. But you'll see this has switched me to the regex tab. So regex stands for regular expression, and you can think of it for now as just being an extension of full text search. So any full text search term that you could enter in here is going to be a valid regular expression. But the power of regular expressions is that you can also search for things that are not just straightforward full text search. You can search for patterns, for example. I'll give you some examples of those in a minute. I'll come back to that a little bit later, because that's also something which is quite useful to be able to do, and you can do very easily in this tool, and you can also do in many other platforms and tools as well. So almost all of the things that I'm showing you today are not specific to this particular tool, but this particular tool gives you one way of experimenting with them and deciding whether any of these things are going to be useful for your materials. So just going back to the n-grams thing, so if I tried a different value of n, say n equals 2, I would instead have got all of the collocations in the analyte. So now you can start to see things like, well, ziyue is something that's inordinately common in the analytes. That's the most common character pairing here. You have other things, some of which are going to be words, things like junzi, but also various grammatical combinations of grammatical terms and other words. So you can, if you are interested, use this kind of tool to perform very simple comparisons between texts. I'm just going to show you that, not because this specific example is interesting, but because the general logic applies throughout this tool. So if I wanted to make a comparison between, say, the analytes and the mengzi in terms of character collocations, the first thing I would need to do would be to change my list of texts here. So at the moment, I only have the analytes here. And if I want to load in the mengzi as well, I can't just do that by using the ctext user interface, because if I go to mengzi in the ctext, so if I open the mengzi and if I click text tools, I'll just end up with another window which only has mengzi in it and doesn't have analytes. So instead what I need to do is to copy this URN, the one that corresponds to the text that I want from ctext, go to the instance of text tools that I want, paste it in here and click fetch. And then once I've done that, I can either just keep going or I can click save, and you'll see that you have these two things loaded here. You'll notice that the output here hasn't changed. None of the output will change until I ask the tool to do something again. So if I want it to do the same thing again, but now to my new list of text, I would just hit run here again. And now what I'll get is the tabulated results for these two texts. So I'll have the comparison here. And again, I'm not going to be able to go through every single possible function that's listed here. One of the functions that appears for many of these outputs, including things that are tabular like this, is the option to chart them. So if I click chart, I will then get a chart of a subset of the data that I was looking at. So you'll see, if you remember, I said that every single possible combination appears here. So of course there's a lot of combinations here. So the chart that I'm actually looking at, in fact, is not all of the data, but only part of it. It's only showing the first 40 rows of this data, and I can change that if I want. I can maybe make this graph a little bit clearer if I change it to 20 instead. This is just comparing the analytes. So there's a key here. The analytes are these green bars versus the mengzi, the blue bars, for all of the terms that were in that data set. So you can see, for example, unsurprisingly, mengzi is not very well represented in the analytes, although in fact that collocation does occur once. For this particular example, this is fairly trivial stuff, but the same approach applies throughout the tool. So this will also apply to more sophisticated searches that you can do on the basis of particular hypotheses or particular word usages that you want to look at, in which case you would probably not be starting with the n-gram tool, but instead starting with the regular expression tool. But this sort of gives you an idea of the logic of the way the tool is supposed to work. Again, clicking on the bars in the chart should hopefully show you the specific occurrences, or should take you to the regex tool to actually look for that specific term in the text if you want to see what the specific textual sources are for them. Okay, so that's probably more than enough about the n-gram tool, because that's not the most interesting one. One of the most easy to use and potentially interesting tools in here is this tool called similarity. So similarity is basically applying this idea of n-grams, but in a different way. So the idea here is when we looked at n-grams, we were looking at things that were repeated in different places. And I'd so far only chosen n equals 1 and 2. But if I'd chosen, say, n equals 5, you'd start seeing certain things that occur in the analytes in more than one place that you might not necessarily expect. So these are collocations that are not kind of trivial one-word collocations, but things that suggest some kind of content similarity between different passages of text. So this is where this idea of looking for n-grams comes back to that example of parallel passages that I showed you in ctext earlier on. Because looking for identical strings like these, so this is where you have things like 人字不自己, 不己字 appearing in multiple lines of the analytes. Finding identical cases like this is something that computers are really good at, because they can perform all of these calculations in a fraction of a second. The similarity tool basically allows you to perform that task in a slightly different way and to present the results to you in a way that's much easier to navigate the details of. So again, the logic here is that the most important thing you should choose are, first of all, the text you want to apply it to, and then secondly, the value of n that you're looking for. So the value of n here, if we're thinking of text reuse, is basically the shortest chunk of reused identical sequence of characters that you want to have in your results that are produced. So if we go ahead and hit run with n equals 6, you'll see a kind of visualization over a textual copy of parts of the analytes of all of the passages which contain this specific feature that we asked for. So all passages of the analytes where you have 6 characters or more in sequence that also appear somewhere else in the analytes. And that's what all of these red and pink sections highlighted in the text are. Every single one of these is something which occurs identically somewhere else in the analytes. So this, as you'll see, this is one of several tabs of information that are produced in the output. The first thing to mention about this particular output is one of the obvious questions you might have if you see something like this is, well, where are the other occurrences of this thing? So again, this is supposed to be interactive. If you click on one of them, it will then highlight in your list of text or texts precisely where the other occurrences of that exact string are. So here this Chaoyan Lingse part appears in 3 places in the analytes, for example. And the same logic obviously applies if you have multiple texts loaded, which is one of the sort of obvious applications of this tool. You'll see when you do that, you get this thing here that says constraints. All this means is that because you clicked on this particular part, or if I clicked on some other part, I'm setting that as a constraint and only showing here the passages which both have text reuse of this type and also match this constraint that I asked it for. Part of the reason for implementing it like that is that another thing that I could do would be to say, click on a title of one of these subsections, one of the chapters of the text, and then see only those parts which overlap with that specific text, which overlap with that specific part of the text. So if you're looking for text reuse in something that's fairly short, this may be enough because you may just care about all of the instances and so want to look at each of them individually. And you can kind of tune this process to some extent by changing the value of n. If you choose a much longer value of n, you're going to get fewer results because fewer things are going to match that. And if you choose a shorter value of n, say 4, you're going to find that some things are going to be slightly trivial. So for example, this tool is not making any kind of grammatical analysis of your text. It's just literally looking for characters that are identical. It ignores punctuation, but that's about it. So 自约学 is an identical match. So depending on how many of these you're willing to sift through to find the information you're actually looking for, you may want to play around with this value of n. But if you're looking at larger amounts of text, or if you're interested in larger scale patterns, then this is where digital tools can really help you summarize information in a way that's intuitive and helpful. So that's what a couple of these other tabs here in the output attempt to do. The first of these, chapter summary, provides, first of all, just a very simple table comparing all of the units in your analysis with all of the other units. So here these units are just labeled chapters here, which are, in our case, are just the chapters of the analytes. And this is just telling us, firstly, how many n-grams did these two things have in common? How many things were repeated more than once in these two texts? And then the length of the two texts. And the last column here is just a calculated metric of proportionate to the length of the two texts, how much reuse was there. So this is basically based on the idea that some things are going to be really long and some things are going to be really short. And so what we really want to look at is a proportion of reuse rather than the absolute number of reused n-grams, because if we have a text that's 10 times as long, it's more likely to have more reuse on the whole, even if it doesn't proportionately. So this table, and I should say again, well, I haven't actually said it yet, I should say all of these tables will have this link export CSV. If you care about the data, which you might do in this case, or for some of the tabular data, the export CSV link will give you a CSV file, which you should be able to open directly. If you have Excel on your computer, you should be able to open it directly in Excel. That may not be installed on this computer. If I did have Excel on this computer, then this would appear just as exactly the same table, but in a way that you can use for saving or for further analysis or whatever you want to do with it. But what I want to show you here instead is a visual way of summarizing this data using a network graph. So this create graph link here will take you to the network tab of this tool, and it'll produce this kind of code at the top here. Now, if you've used any other software for network visualization, if you've ever heard of Gephi, which I think is going to be mentioned in one of the other workshops later today or tomorrow, you may be familiar with this. This is basically a specification of a graph. In other words, this is a way of saying what objects are there and what edges should there be to produce the kind of visualization that I showed you the static version of earlier of the Preachin and Han. So it's produced this information, and if I click draw, it will then turn this into that kind of visual representation, where here what we're looking at are all of the chapters. So each of these circles represents one chapter of the analytes, because that's the text that I had loaded. And then each of these edges represents the fact that there are some n-grams. There are one or more n-grams that are identical between these two textual objects according to whatever parameters I put in the n-grams in the similarity tool when I chose it. So this, obviously, you can zoom in and zoom out, which already is a slight improvement over the static PDF. But the bigger improvement is that this is also designed to be interactive. So you can look at this and sort of get some idea of what picture of reuse is going on. There may not be many conclusions we can draw from this simple example so far, but you can immediately see some obvious features, for example, that these two pairs of text have a significant or a large amount of reuse. So that's expressed by these thicker lines. Thinner lines correspond to lower proportionate amounts of reuse. Thicker ones correspond to more reuse. If you double click on one of these edges, it'll then take you back to the textual visualization and show you these are the specific similarities that correspond to those two textual objects that you chose. And again, you can go back using the network tab back to the graph, and you can do this for any part of the graph. So this is conceptually the interactive version of the static kind of picture that I showed you at the beginning, except that now, although we're using more simplistic data because we're just using the simple n-gram analysis, this is more powerful in that you can put any text you like into this, any selection of text you like into this, immediately produce the visualization, and also see the textual features for any part of it that you like. So this, okay, maybe kind of different orders that I could go through this in. I guess, okay, so there are these different tabs to the output here, and generally each tab in the output of text tools is going to give you different information about the same kind of thing, or different ways of visualizing the same information. The third tab here is a similarity matrix. And you'll see when you click on that, the first thing you get is this slightly ugly table with all of these numbers behind it. That's somewhat intentional because these numbers are the same numbers in here. So the numbers are there to give you an idea of where the data comes from. But this visualization is probably easier if we turn off the numbers by clicking toggle values. And then it becomes sort of clearer what's going on here. So this is another way of visualizing the same information, where we're seeing all of the textual objects, so each of the chapters of the text of the analytes here, being compared with all of the other textual objects, so all of the same things again. In other words, each cell in this table represents a comparison between a pair of chapters. So this cell here, for example, represents a comparison between Shenjin and Yongye. And the colorization here, this shade of red, is designed to indicate the strength of text reuse. So this gives you a different way of viewing where reuse is occurring in your text or set of text. And again, obviously the logic is that this is interactive, so if you want to see specifically what are the similarities that correspond to that part, you click on a particular cell. So far, using the analytes as an example, we don't really have hugely interesting or persuasive results. The results will be more interesting if we start using more complex textual objects that have larger amounts of interesting reuse that could be summarized in ways that might tell us things about the text. So the Mozi, which I'm going to load in here, is a really good example of this. We can load in the text of the Mozi, and I'm going to try this just so we don't get too much noise. I'm going to set n to 8 and do exactly the same thing. So if we go in here and create the graph and now switch to the Mozi text, you'll see here, every time you run this tool, particularly the network graph visualization, you should be very careful about interpreting some features of these visualizations, because this visualization is partly determined by random factors. Some aspects of how this is displayed are not inherent in the data, and some are. So the question of which nodes, in other words, which of these circles representing chapters are connected to which other ones, and how strong a bond there is between them, this is determined entirely by the data. But some of the specifics of how the layout is made, in other words, whether this point is here, in fact, you'll see if you use the tool, you can actually drag it to modify the visualization. Some aspects of this are not at all fixed. They're essentially random or say nothing at all about the data. What you can see from the data here very quickly is that there are these disjoint clusters where you have reuse within a section of materials. So you have reuse between these chapters and these chapters and these other chapters, but nothing at all, no connection with the rest of the corpus. And if you're familiar with the text of the Mozi, and if you actually zoom in and look at which specific chapters these are, you'll see that there are pretty clear reasons for for this difference here. So these are all chapters that occur at the end of the Mozi. They're almost certainly of different authorship to the rest of the main body of the text. They have very different thematic concerns. And it turns out, as you can see immediately, even without zooming in or seeing what the titles are here, they have very different text reuse properties with the rest of this, what purports to be the same transmitted text. Something similar applies to, this pair, which I think should be the Xiaoqiu and the Daqiu text of the Mozi. So it gives you a kind of bird's eye view of what's happening in terms of text reuse, particularly in terms of relationships between individual items and groups of items. Part of the power of this tool is that you can just as easily do the same thing with multiple texts. So you can add in, for example, the text of the Xunzi, say, and a text of the Zhuangzi, and if you rerun this analysis, what you'll see now is that there's really too much data to look at it in this matrix view because we would have to zoom out so far. But if we look at things as a network graph, again, you can see fairly large-scale patterns at a distance and also be able to zoom in and see what the detail is. So in this case, the colorization that's used here doesn't form part of the analysis. The colorization here is just indicating which chapters came from which textual object. So we will have the Zhuangzi here in this light green color, and we have the Mozi, I guess, still in the blue over here, and then we have the Xunzi as this text here. So you can immediately see large-scale patterns here. As you would expect for these classical texts, most of these have a lot of internal text reuse within their body of materials and a smaller amount of overlap with certain other texts. And it may be this certain amount of overlap that you're interested in, and if so, this provides an easy way of seeing where it is and zooming in and seeing what the textual details are. So again, this is an example using materials from CText, but you can use whatever materials you like to do this. So I'm just going to go back to the Mozi example and rerun this just to show a similarity matrix where you can see interesting features that are much more interesting in this case than they were in the analytes example. In fact, maybe we should look for more data here for a larger number of overlaps. I'm not sure whether this is, it's probably fairly visible on the projector here. This is a zoomed out visualization of all of the text reuse in the Mozi, and you can actually see very neatly here the core chapters of the Mozi are basically represented by this pink square here, in which you have a continuous group of materials at consecutive chapters, which it's not the case that every chapter has a text reuse relationship with every other chapter in this group, but on the whole they tend to. That tends to be the case within this group, and it tends not to be the case for the rest of the Mozi. It also tends not to be the case that materials in here have significant overlap with any other part of the text. So these are kind of aggregate features of properties of text reuse in this text, which would be relatively difficult, certainly not impossible, but relatively difficult or not trivial to discover just looking at the instances or just looking at the text. So this is a nice example of how summarizing this data can be useful. It's also a nice example if you go into the specific details, and we don't really have time to go into the details of the Mozi here, of how this visualization as compared with the network visualization can also draw your attention to absence of a feature where you might otherwise expect it. So within this square of materials here where things tend to have these reuse relationships, if you look closely, you'll see that there are certain chapters here, there are certain rows where there's essentially no reuse with anything else within this cluster. And that's a very unusual feature of mainstream chapters of the core Moist dialogues, the core Moist doctrines, that they should have no overlap with the rest of this body. And that applies to several chapters of this body of text, which are unusual for other reasons also. So again, that's something which is non-trivial looking at just where the reuse is, but this summarization of it in a visual form can hopefully draw your attention to things that may be interesting to you given other features that you know about the text or other hypotheses that you have about them. So that's kind of the general motivation of this tool, to provide you with summarization of more data than you could really look at. Of course, if you were a computer, sure, you could go and look at all of this numerical data. But if you're a human, instead of looking at this endless table of data, it's much nicer to look at a visualization that makes features jump out to us in certain ways. Anyone have any specific questions about this part before I move on to something else? Yeah. Oh yeah, so yeah, that's
Always the same color?
yes, so that's the sort of standard computer science question for this. Why is the diagonal not solid? The diagonal is not solid because I'm trying to convey more information in here, and the information that the diagonal is conveying is the rate of text reuse within that particular unit. So in other words, this cell here represents Sturgeon versus Sturgeon. There are two ways of understanding that question. One way would be to say literally how many n-grams in Sturgeon are also in Sturgeon, and if that's the way you understand it, then always that's going to be 100%. The other way is to say, well, how many things appear more than once in Sturgeon? And so that's the way it's being understood here. In other words, this should be understood in the same way as these other cells, in that this means that phi has a certain amount of reuse with phi, rather than simply saying phi is the same as phi, which it certainly is. But yeah, so it's slightly unusual in that respect, but I think this is more useful because it conveys that extra piece of information. So you can immediately tell, for example, that this text, although it has no reuse with anything else, it has internal overlap, and in fact a surprisingly large amount of it. Okay, so we don't have a lot of time. I do want to give a couple of examples of particularly using regular expressions, and then possibly quickly look at the vector space model if we have time. So if we go back to an easy and short example of something like the analects, we've actually used the regular expression tool a bunch of times. Because any search phrase, you can type in any search phrase you like in here, and it will search for it and works just like full text search, a bit like full text search in CText. One difference is you can use multiple lines, so each line is going to be treated as a separate search term, and you'll get all occurrences of any of these terms anywhere in your set of text is going to be produced here. So I'm only mentioning that because it might seem like a trivial thing, but it actually can be quite useful because the system can summarize the data for you in various ways. And the way it summarizes the data is going to depend on what set of options you choose here. Some of these may be different because they may be modified by the other parts of the tool. So if you want to actually, so for the sake of argument, if you wanted to get a tabulated list of all of some set of terms, and I've just got randomly selected three terms here in the analects, you can very quickly ask the tool to go and count these for you. In addition to producing this textual output, it'll produce a list of counts. Obviously, the list of counts of how many times they occur, that's something you could trivially do in CText or any other full text database. But it also gives you the option to group things in various ways that will tabulate this data for you. So you could, for example, ask it to group these by chapter. And so the textual results will still be the same. But instead, now you'll have a list of, for every chapter in the analects, all of these terms. And there's no specific limit to 3. You could have 100 terms in here, and it would still produce this entire table for you. You could also, if you wanted, ask it to take into account the length of the chapters, so that instead of just telling you how many times the terms you're interested in occur, what is the proportion at which they occur, taking into account the length of each of the textual units. And if you did that, you'll end up with this sort of messy looking data, but you could export that to Excel, or you could create a chart of it to see what's going on. And this will chart, so this is now charting the relative proportions of those 3 terms, which I happen to choose here throughout all of the text of the analects. And obviously this also will work if you have more than one text. The regular expression tool is in many ways more interesting when you start looking at pattern search. We don't really have time to cover how to write regular expressions here, but there are a few very trivial pieces of regular expression syntax, which once you've learned how to use them, and it doesn't take very long to learn how to use them, are actually extremely useful. So one of these is the syntax which matches a word character. In other words, at least in the context of this tool, any Chinese character, but not any punctuation character. And the syntax for that in this tool and in many regular expression systems is \w. So if I'd instead typed \w here instead of typing in a specific term and just ran this regular expression, it would take a while, but a while, maybe a second, but it would match every single character in the text of the analytes. So you'll see now that the textual visualization of this information is not particularly useful. It's just telling me that all the characters are characters, although it's a good sanity check that this did match what I wanted it to match. But if I go to the summary, then in fact, now what it's done is matched every single character that occurs anywhere in the analytes in every single chapter, separated by chapter, what's the proportion with which that particular term occurs. So this has produced an enormous amount of data. I don't specifically want this data, but if I did, I could produce it very, very quickly and easily like this. Normally what you're going to want to do is, with the regular expression tool, is to look for particular types of pattern, and these could be linguistically motivated, or these could be specific types of thing that you're looking for, or they could just be regular search terms. So to give a trivial kind of example, if I typed in, so we had all those ziyue, I could just say, well, what are all of the things that occur after zi in the analytes? In other words, zi followed by something. Then you'll see, and this is quite a good way of experimenting with regular expressions if you're learning how to write them, how to write these pattern searches. You'll see here, first of all, highlighted all of the possibilities, so most of them are ziyue, and you'll see again, this isn't taking into account word segmentation, so you ziyue is just treated as 3 separate characters, because we haven't used tokenization here. It is possible to use tokenization in this tool to take account of word boundaries, but the prerequisite for that is that you know all of the word boundaries in your text, which is going to be harder for classical Chinese, although there may be things that can help you with that. But again, you'll get the summarized data here, and you can sort of start to see some sort of patterns here, and you can basically build this idea up in various ways to search for particular things. So one kind of trivial example thinking of the analytes is, well, there are all of these cases and so says something. What are all of the cases? How many times do different people speak, or are they introduced in different ways? You can very easily write a regular expression that matches something closely connected to that. So as I say, we don't have time to introduce regular expression patterns here, but one type of pattern that you can write is a repeated one, where you can have a particular term or type of term repeated some specified number of times. This regular expression here just means any word character, one time, maybe another word character, maybe another word character, any number of word characters, followed by yue. And if I run that, then you'll see in the summary that I get this nice summarization of how all different people have been introduced, how many times in this particular text. So you can build that idea up to search for all sorts of different kinds of things, particular linguistic expressions, repetition, if you want to look in something like works of poetry, for example, for particular patterns of repetition, you can use regular expressions to look for these and immediately identify and collate the data across large amounts of material just by being able to write these patterns and use this tool. Okay, so we've got 15 minutes left. I guess since we're on regular expressions, I'll just quickly show you something else that you can do with regular expressions as a slightly more realistic version of pattern matching. So this is a kind of example. If you're familiar with the China Biographical Database project, this is kind of motivated by some of their descriptions of some of the work that they do in terms of extracting data from historical textual materials. One kind of search, so you might start out, and I'm going to need to start out by finding an example in ctext of a biography in the Songshi. So we have biography here, for example, of Wang Anshi, and it starts out by saying, well, is this guy, and he has this zi, and he was from this particular place, or he was a person of this particular place. If you look through the Songshi, you'll find there are actually lots and lots of occurrences of very similar things. One way to quickly see some of those is if we just search for other examples of this location. You'll see this is in many ways a kind of fixed phrase, a fixed expression in the song. So very often this is used to introduce somebody at the start of their biography. And this is exactly this kind of pattern that a regular expression can very easily match. You can write a regular expression very easily that would match any one of these things without specifying to the computer which specific name or location or whatever else we're looking for. And it can just match everything that matches your specification. So just to show you quickly how easy that is, I'm going to start another copy of text tools with the Songshi. So this is now quite a long text, so it might take a little bit of time to load it and then to run the regular expression. But we can take the thing that we found a concrete example of, and then we can say, well, okay, so I want to match things that are like this, but not specifically this. And so one strategy for doing that, if you're looking for a particular pattern, is to go through and replace each of the parts that you'd be happy to have anything in with an expression that means some sequence of word characters, which is what that means. Replace each of the parts like that. And basically, if we run that draft regular expression, hopefully we should get some results in here. So as I say, it's probably a mistake to run this on the whole of the Songshi, but there you go, very quickly we have summarized data of all of these individuals in the Songshi, sucked out of this entire text and put into a table. And of course, if you were actually doing this in practice to do real text mining to extract data, you'd have to be very careful about whether these things are really matching all of the cases that you're looking for. You would want to check that, for example, in the textual visualization here, and you'd want to make sure that there weren't any false negatives where you'd missed things out because they didn't match your regular expression. But actually what I wanted to show you here is that in fact this actually gets even more powerful, because another thing which regular expressions allow you to do is to specify that you're interested in particular parts of the thing that you're looking for. So if you look at the results that we had here, it's just matched every single thing as an individual string, but we don't really have a neat list of individual people and which locations they're from or anything like that. But by modifying a regular expression by adding parentheses around particular parts of it, in regular expression syntax this is called grouping, this will cause the system to have access to the information that occurs in these specific places. So if I now I have to be a little careful about how I'm using the tool. I need to tell it that I want to extract the groups here because I want to get this information. And hopefully if we run this, we should get the same results. So we haven't got the results yet, it hasn't finished running. We should get the same results, but now we have this nice tabulated content where the name of the person, okay, so there's some specific differences here. There's some sort of exceptions to the rule, but generally speaking, we have the name of the person, we have their tsu, and we have the place which the text in the biography is saying that they're from. And as I say, although this computer doesn't have Excel on it, if I was running this on a computer with Excel and I hit export CSV, I would immediately have this in tabulated form that I could then go and do other things with. Yeah?
Which means you could then probably find out how many people from this town.
Exactly. Yes. So for this example, that would be something you could immediately do. You could say for each particular town, how many times is that town or location represented in this data. You could probably do that with text tools, but it would be much easier to do if you also had Excel on your computer. If we had Excel, I would open this in Excel, copy this column, and then paste it back into text tools. In fact, actually, that's a good point. That's another thing that I haven't mentioned at all, which is really important here, is that the way this tool works, when we've been loading all these things from ctext into this tool and then just using them exactly as they arrived into the system, but a bit like the wiki section of ctext, this text here is completely editable. So there's nothing special about, okay, it's a bad idea to edit something that is this long, I guess. There's nothing special about the textual representation or the textual materials as they are in here. We can modify them arbitrarily to fit with what we actually want to do. So I guess we're kind of running out of time, so I guess I'll show an example of a different, let's see, what's the best example to show quickly. Okay, so maybe go back to the mods example just because that's quite a short and intuitive one. So if we close this and load the mods in here. Oops. When I did the similarity comparison here, I just ran this as it was, and so we got the colorization for a single text in here because the modes is a single text. But if I had some particular hypothesis that I wanted to test against this, I might want to colorize some parts of this material differently from other parts. And the easiest way to do that in text tools is basically to redefine your texts. So here I have the text of the modes just as ctext sees it. It sees it as a thing with 53 sections in it. But I might just decide that I have a hypothesis, say, that the latter half of the text, starting from, say, the Jing Shang chapter, is in some way different to the rest of the materials. And so really what I want to do is for text tools to treat these two things as being separate. And if I want to do that, I can just do that by modifying the text. There's nothing that says I can't modify this text. I'm just going to cut all of the text from there onwards, cut it to the clipboard, and then save this. And now the modes, or the thing I'm calling the modes, is only 31 chapters long. And then I'm just going to create a new piece of the text and just paste in the thing that I created. And now I have another thing that's 22 sections long. So now I have these two separate things. Text tools doesn't care whether these are really text or not. It just cares that you have objects you want to treat differently, and they have divisions of some kind within them if you want them to. So if I now run the same kind of analysis in similarity, I should get the same results, but the colorization will be different because it's going to treat these as being two separate things. So I can use this to kind of test my hypothesis about how these two groups of things are related. So this is the kind of thing you might do if, say, you were interested, and I was going to try and show the example, but it might not be time, in something like the authorship of chapters of the Hong Lu Meng, for example. If you want to visualize different chapters, different groups as belonging to different sections according to your hypothesis, this is how you would do it using this tool. You just redefine your texts and give them whatever labels you want. That's probably also a good idea to mention that, as I said, this does not save any of the state, and none of the stuff that we've been doing has been uploaded to ctext. So if I close this window, this will be gone forever. If I wanted to save this modification to the textual objects that I've made, I would just be able to go to the Save Load tab and click Download Corpus. And if I do that, I'll get a zip file which contains just exactly the it should just contain exactly the files that correspond to this material. So if I go into this zip file, I'll find that I just have two texts, one of which is labeled Moza, but this isn't the ctext Moza, this is my modified one, and the other one, the second part text, is just a text file with this material in it. So this is also how you would get your own materials in here. If you don't want to use ctext materials, all you need to do is either create a zip file or just create text files on your computer, and you can just drag them onto here. You should be able to. Look at the right screen. And they should open in here. Don't know why they're not opening in here. We're using Internet Explorer. Strange. Oh, this is because we're in Windows, and these are not really text files, I think. I would have to unzip this zip file, I think, possibly. Yeah, I have to unzip the zip file. But yeah, you should be able to just drag the texts in here and get them back. So that's how you kind of continue your work if you were doing this kind of approach, or use your own materials. Okay, so we're almost out of time. I'm going to close this. Load the whole of the text of the mods. I'm just going to show you very, very briefly something called the vector space model. So we looked at, when you're looking at n-grams and things, it's very easy for a computer to go through and say, well, what are all the terms that occur in your corpus? And if you wanted, you could have it tabulated by chapter or whatever else. Those tables are kind of horrific for human beings to look at, but in principle, there's nothing preventing a computer from making comparisons on the basis of these frequencies of different terms, even all of the terms that occur anywhere in all of the texts, across large bodies of text. And that's really what the vectors tab in text tools does. It looks at term frequencies, so frequencies of different, all of the terms by default that occur in your corpus of materials, and how these compare across different textual units. So this will produce by default a similar kind of matrix visualization as we saw with text reuse, but here what's being represented is instead something called cosine similarity. So this, here we do have the diagonal line that you were expecting in the other graph, because now what we're comparing is aggregate vocabulary use across individual texts. So here, what we're comparing in this cell is the vocabulary of the Qinshi versus the vocabulary of the Qinshi, which, however you look at it, has to be the same. It just is the same. There's only one thing there that we're doing, and so it has to be 1. It has to be 100%. It's as similar as it could possibly be, and that's represented by red in this chart. But what this chart, again, gives you the possibility of doing is looking at large bodies of text. Here again, this is the entirety of the Mozi, but now looking at least one way of summarizing the complete vocabulary use of every chapter of this long text as compared with every other chapter. And again, a bit like in the case of text reuse, the interesting features, at least in the Mozi, are ones where you have these little squares along the diagonal that correspond to sequential chapters which have very distinctly similar vocabulary use. And again, if you know much about the structure of the text, these will not be particularly surprising. The grouping at the end here is exactly that same group of military texts with this very different vocabulary usage. But again, what this tool gives you the possibility of doing is to actually look and use this visualization as a way of navigating the data to see specifically what vocabulary use is it that's surprisingly similar in these groups of text. So if I choose one of these comparisons here at the end between two of these texts in the group here, I will then see this rather long table here. So what's listed in this table is, again, every single term that occurs anywhere in the Mozi, but crucially sorted according to the contribution of that term to the similarity of the two textual objects that I chose. So I chose to look at this particular pair of chapters down here that according to this particular metric of similarity have vocabulary usage that is more similar to one another than the rest of the corpus. That's one sort of intuitive way of understanding what's going on here. And the comparison that I'm being shown here is in terms of which specific terms contribute the greatest amount to that overall result. So in other words, this is a hugely long table, but the only interesting features of the table are going to be the first 1 or 2 rows of it. And what this is basically telling us is that it's this specific character, this specific character, this specific character that is contributing to the unusualness the global similarity, the similarity versus the rest of the corpus of these particular chapters. And that's kind of difficult to explain. It's difficult to explain in words, but it's much more simple to understand if we actually click through and look at the distribution of these across the corpus. So what's being plotted in this chart now is the specific term that I selected, in other words, this ch, shown as a histogram throughout the Mozi. So every chapter of the Mozi is represented along the bottom here with the relative frequency with which that particular term that I looked for occurs in that particular chapter. And you can see in the mainstream part of the Mozi, this term basically never occurs. It almost never appears. It appears in a few isolated places. But then when we get to this distinctive grouping at the end, you see this is actually a very common piece of terminology in this subset of the chapters of the Mozi. And this is why those two particular chapters that I chose have this high degree of similarity. So this is the kind of thing that the visualization is supposed to give you access to, rather than simply saying, okay, in aggregate these things are similar. It gives you a way of introspecting that algorithm and seeing, well, in what specific way in terms of textual features are these things allegedly similar? And you can then use that data to go back and look at the corpus and see for yourself whether these things being co-referenced to a high degree in this particular pair of textual items is interesting or is not, or whether it's a trivial feature or one that's interpretatively useful. So if we look at this pair, for example, it's an entirely different set of terms here which are causing these adjacent chapters to be related to one another. Terms like Shen, for example, are overrepresented versus the rest of the corpus in this particular part of it that we're looking at here. And again, the same logic applies. You can use this to compare different materials, different groups of texts and their vocabulary usage one with another. We're very nearly out of time. I'll just show one thing which would require a lot more explanation, but another statistical procedure you can use on any vector data in this tool is something called principal component analysis, which provides another way of visualizing potentially interesting features of these vectors. And you'll see, if you try that with the Mozi, you'll see something quite similar in that all of these chapters with distinctive vocabulary usage have been clustered on the left here, basically on the basis of the fact that their usage of certain vocabulary terms, and it's very likely to be the same, similar ones to the ones we looked at in cosine similarity, are just statistically hugely different from everything else in this body of materials that we're looking at. Again, it's intended to be interactive, so you can go in and say, well, which specifically are the terms, to confirm for yourself whether it really looks like this is a persuasive argument that these things are different in this body of text. And again, this is an example where things potentially become more interesting. Firstly, when you start comparing different materials. So if we compare a grouping of two texts here, and again, the colorization in terms of the visualization that we get is going to represent which textual object a particular thing came from. This is maybe going to take a second. And the analysis itself is, in all of the tools we're looking at here, none of the analysis takes into account differences between texts directly. In other words, the tool isn't making use of the fact that it knows that the Zhuangzi is different to the Mozi. It's performing the same analysis on all of the materials together. And the only way the distinction between the text is being brought in here is in the colorization, which is entirely for our benefit. So this is kind of a visualization of aggregate vocabulary use in the Mozi as represented by red versus the Zhuangzi as represented by green with all of the individual chapters here. You can see, generally speaking, these things are very distinct. This is not exactly the approach, but this is one of the tools which you could use to attempt things like authorship attribution, compare stylistic properties of authors in Chinese texts. If you were doing that, you probably would not generate the vectors in this way. You would generate them using more carefully chosen features, for example, the most common terms in a corpus, or specific grammatical particles. That's also something you can do using this tool. I don't have time to show you it, but if you want to experiment with it, you would start in the regex tab by inputting your list of specific terms that you want to investigate, and then from the output, using the Create Vectors tab, which will then create vectors according to your specification. So this then becomes quite a powerful tool for testing hypotheses about how specific types of vocabulary use vary across a corpus of materials. What we've done here, just using the Vectors tab, was just to look at all vocabulary. You're likely to get more interesting results that perhaps lead to useful conclusions if you have specific hypotheses and you start creating your vectors on your own. But I guess I'm over time, so I should here, and thanks everyone for coming.